Today we'll conclude the chapter on combinational logic by looking at complex conditionals. There are times when a simple if statement can be used to express very complex conditions, and we'll take as an example a priority encoder. The idea is that we have a series of requests coming in, and we'd like to decide which request should we service first. Which request is our highest priority request? And by definition, the request in bit 7 is going to be the highest priority request, whereas the request down in bit 0 would be our lowest priority request. For example, let's say that we have a number. Notice we've numbered our bits from 7 to 1 instead of 7 to 0. The number will be the reason will become clear shortly. Let's say we had this as our input. Our goal is to say bit 6 is our highest priority request. So if this is our input, then we would want our output to be the number 6. There it is in binary and in decimal. And that's the job of a priority encoder, is essentially to take a look from left to right and look for the first one bit it finds and identify that as the highest priority request. If none of the inputs, of the request lines are asserted, then we're going to output 0. Hence, we don't have a 0 here, indicating that there is no request pending, and therefore 0 is kind of a below minimum priority result. So again, just to make that really clear, if our value is all zeros, then our answer should be priority quote-unquote 0 is our current request. How do we accomplish this? Again, it's an if statement. So we're going to place that in an always begin end, just like we would any if statement, any case statement. A lot of the more complex programs, we prefer using that to avoid repeating the word assert again and again on each line. Before assigning anything to our if statement, we go ahead and provide our initial value. Here it makes sense to make the highest priority 0. Of course, this would reflect the case where there are no outstanding requests. And then we use a series of if statements. If request line 7 is true, then obviously our highest priority is 7, and we keep going down the line 6, 5, 4, 3, 2, and 1. Notice that we are not using a for loop. There are ways in Verilog to use for loops. However, most of them can't be synthesized to actual hardware, and the rules surrounding the use of a for loop are outside the scope of this class. So, for simplicity, we just make direct use of a series of if statements here. Let's take a look at an exercise where I'd like you to build on the idea of a priority encoder. Again, stay away from for loops or while loops or similar things like that. They don't synthesize. They require another additional knowledge and that sort of stuff. So again, we simply have a request, and now I'd like two results. We want to produce a highest priority request. So again, thinking back to what we had, in this case, line 6 would be our highest priority requests. But notice that there's a second highest priority that we're required to output. So we like to know not only what is our first or highest priority request, but our second highest priority request. And obviously in this case, that would be priority 2. You can see that's the next one that's available, the number 2. So your goal in this is to produce that second highest priority value. Obviously, from the previous example, you already know how to produce the highest priority value. So here's a suggestion. Create a variable called request second and just set it equal to the request initially. Find, of course, use the code you have earlier to find that highest priority request, and inside it, set the request second value of that highest priority request to 0. Notice what would happen here. Let's say that this is our, as suggested, request second variable. I'll just set that to make it a bit clearer. So let's say this is our request second variable. We'll space things out nicely. And as we find and identify this as our highest priority request, we set that to 0. Now we use the same sort of process that we've already used to identify the highest priority request to identify our second highest priority request. So with that approach, you should be able to, with a little bit of creativity, complete this exercise. I wish you the best. If you have any questions, please message me. Take care.